you need something to lower blood pressure, that's a supplement. This is called Citrinox. This is one of a few things like grapeseed extract.
Yeah,
Has,
you know what?
evidence-based.
That is what we bought. That wasn't helping.
How long did you take it for?
And I don't think he was taking 4 like he was.
Well, that's the thing too. So supplements in general, they're not a prescription. So prescription molecules are very targeted. They can make them very small. Supplements are natural, organic molecules. They're going to be a bit more robust. And that means that you can't fit the potency of the clinical dose in one capsule. That's why you see like 4 capsules a day or 6 capsules a day. That's how much it takes to get that clinical efficacy. You know what I mean? So unfortunately, if he's not willing to scarf down 4, I don't know if he's able to like break. He could do like 2 in the morning, 2 at night, but as long as he's getting that clinical value, okay. Yeah. Fair enough. Otherwise, you could look maybe into just grapeseed extract. That's the one that kind of really has the evidence base behind it.
Okay.
This piece here, it's like kind of branded. They brand that because they did studies on this combination and were able to achieve a level of efficacy. That's why they trademarked it.
Okay.
So like no one else can kind of take their. So when you see that on Orthomolecular, that's great because it's showing you they actually do trials on this.
Okay.
Just as an FYI. You're welcome. No problem. I'm trying to see if I have one of those for you. Oh, here's if you want to read up on, again, from lovely Orthomolecular, all about CoQ10.
Okay.
You're welcome.
Now I might be wasting everybody's time.
Not at all.
I just learned something.
Oh,
Yeah,
good.
that's why I have to take so many supplements.
To find the clinical
Yeah.
dosing, yeah.
Mhm.
In general, supplements are
Mhm.
are kind of organic, and as much as the natural way, I think, is usually the best way, you need more of it, right? So, but it also, like prescriptions are targeted, so they're working in one spot. Supplements, as you'll know, and like vitamin D, you'll get to know about it. I mean, supplements hit so many other areas of your body, and then their ceiling for toxicity, like the level that it takes to get to toxic, is so much higher than that targeted prescription. That's why taking 6 capsules a day is likely very safe, like very rare to overdose on a lot of these, okay? That's helpful.
Yeah.
Yeah, cool.
I'm kind of doing the same thing. I'm taking prenatals and they're like horse pills. I'm like, do I have to take 3 of these? I can take them morning, afternoon, and night or something?
Yeah, spread them out a little bit. That's
Yeah.
fine. There's very few, and I can't even name any supplements I know of that are concentration dependent. I was just talking to someone about that. Usually concentration dependent medications are usually for eradicating something. Like you have antibiotics that have to eradicate, so it's concentration dependent. Trying to think of the antibiotic that is. But as far as supplements go, that's really not the case.
Okay.
Dan, do you know of any concentration dependent supplements? Putting you right on the spot.
Not at the top of my head.
Right?
Yeah.
So if they have to take 4 capsules a day, in theory, they could take 1, then just
So
maintaining a level.
I can give you his phone number and you'll call him.
I mean, he's his own man. I can nudge him, but in the end, and freedom of choice there. I think you have more influence on him.
We're ready to go.
Oh, okay, we're
Yeah,
gonna go?
yeah.
All right, not a problem.
Do it.
Make sure I got my clicker working okay. So I'm gonna be blocking you guys out. Literally.
okay.
Okay, just listen to my beautiful voice. Do I start now?
You can start now.
Are we live
We're
streaming?
live streaming.
Oh,
Yeah.
well, hello. All right. Well, I didn't know that. I'd like to thank all of you, okay, for coming to the seminar about vitamin D. My name's, Dr. Dane Newville. I'm a doctor of pharmacy, registered pharmacist with the state of Wisconsin, of course, with the United States as well. You have to take tests for both. I'd like to thank MD Custom RX for letting me be employed and learn about functional medicine, and then being able to have an opportunity to teach, what you learn along the way as well. So we'll jump in. So vitamin D, I mean, the subtitle, I think, kind of alludes to it. And I think we alluded to it with the flyers, but it's a well-known vitamin, of course, a little-known hormone. I'm hoping at the end of this, I change your mind completely on what vitamin D is. That's just a misnomer. It's a hormone. It should be hormone D. So medical disclaimer, you'll see these on all of our videos. This is my first one, by the way, so bear with me, but Dan has this on all of theirs. This is all going to be statements, not opinions, but statements, evidence-based, at least mine, right, and all the others too, likely. But the scientific information that's currently available, these are suggestions though, okay? We don't condone you doing this without talking to, your provider. As far as adding medications or supplements without consulting, we don't take any responsibility for that, okay? But anyway, that's done. Moving forward, what we're going to talk about today, who's at risk for deficiency, what it is, how vitamin D becomes active, which will be pretty cool, the benefits of vitamin D, which obviously is the best part, and how to test vitamin D levels, because that is actually important. So moving forward. And then if you guys don't mind, if you do have questions, feel free to write them down, but I'll take questions at the end, if that's okay with everyone. Thank you. So we're going to jump into what's a hormone. We have to define that in order to, place it against what we think this is. So this was just kind of a definitional find, but it's just a regulatory substance, but it's produced in an organism. What are we? We are organisms, right? Transported in tissue fluids such as blood. That's stimulating specific cells or tissues into action. Another definition is going to be very similar. Any member of a class of signaling molecules. So you can remember signaling molecules, of course, in a multicellular organism. That's us. We are multicellular organisms. Kind of saying the similar stuff, just transported by intricate biological processes to regulate physiology and behavior. So that's another one to know about. So now we've defined hormone. It's good to know. Every now and then you're going to see this. If you can't read it, it's okay. I'm just kind of referencing where I got that information. It's likely a study or a comprehensive review, meta-analysis. We will go over kind of what those all mean too, because those are important when you're making kind of claims about something to have evidence base, in my opinion. So who may be at risk? Well, believe it or not, about 1 billion people, and I think, what are we at, 7.5, I don't know these days, but about 1 billion people worldwide have a vitamin D deficiency. That's defined as under 20 nanograms per milliliter. So in the United States, kind of interesting, 35% of the adult population are vitamin D deficient. 3, 6, 9, 10 of us. 3 of us are deficient in this room. I mean, likely we're more of a select demographic, right? Taking care of ourselves. But if you took 9 people out of the general population, 3 of them are deficient. That's pretty spectacular. This one is also a pretty alarming statistic. 61% of the elderly population in the U.S. are deficient. 61%. That's more than not. More than not. Again, reference there. So latitude, ... I thought I'd have a little fun with this title. You'll get it at the other side. Latitude is significantly associated with the prevalence of multiple sclerosis, or MS. That was found from a meta-analysis. And again, I'll kind of tell you a little bit about what those are. In brief, a meta-analysis is a study that takes all other studies with similar parameters, so similar characteristics, and then using qualitative and quantitative statistical analyses, they find the common denominator. So they find what essentially they're trying to validate if there's any sort of common denominator. It's a really validating way to find something, some truth. Okay. So latitude, when they say that, the globe, latitudinal would be like from North Pole to South Pole. If you're moving down, these are latitudes. The closer you are to the equator, the less likely you have MS. The farther away, the more likely you're going to have MS. So this was right out of that study, this being the most comprehensive review of MS prevalence to date, has confirmed. And so when they say a statistically significant positive association, that statistical significance is how drugs come to market in the traditional side. Statistical significance is everything. So if you have a statement saying statistically significant, that's significant going to the market if you're a traditional drug manufacturer. Not that we're comparing ourselves to traditional medicine, but like just giving you kind of a standard you might be more familiar with, okay? So that's pretty interesting, right? Why does that matter? So latitude and your attitude. Woo, I thought that was a fun little title. Vitamin D deficiency and depression link. So you're going to see all these numbers here. I know it's hard to see, I apologize, but I wanted to get actual study information in front of you so it can validate things. These are all references out of the study. So if you guys actually want to dig into these, I can get you this reference and you can pull those studies up. But long story short, they took several cross-sectional studies, cohort studies, meaning people have similar characteristics, case control, meaning one group versus the other, to examine an association. That study found that depressed subjects had lower levels of vitamin D compared to controls, and those with the lowest vitamin D levels had the greatest risk of depression. They also found in that same study, which it's not one study, it's multiple studies, they found that vitamin D was correlated with the severity of depression. So depending on very severe depressed or very low in vitamin D levels, mildly suppressed. So there was a correlation there. So that's something to note as well. So vitamin D, a brief overview. I kind of went kind of a cartoony route, which is cool, I thought. So obviously you can get, on this side is in the inactive molecule. So ergocalciferol, also known as D2. Cholecalciferol, also known as D3. Notice chole, it's made from cholesterol, so cholecalciferol. This little guy right here is actually in a layer of your skin. So it's a precursor. You have a pre-cholecalciferol in the form of like a cholesterol. UVB light from the sun hits it and actually activates it, converts it to D3. So that's where you're getting vitamin D from the sun, if anybody wanted to know. Otherwise, you get it from like fish and like egg yolks or some dietary foods that can provide that for you. But that eventually gets over to this called calcitriol, which is the active form. And we're going to walk you through that. But note, it's a steroid hormone made from cholesterol, fat soluble, just something to note when we're moving forward. So these are Western blots, and this is upregulation of a calcium channel based on essentially what vitamin D is doing. And then so this is serum calcium Western blots. This is actually a rat's kidney. This is like the Luba Henle. This is a distal convoluted tubule. Kidding, we're not going to learn this way. We're not learning that way. But you will find these in those studies, and they're fruitful, but just not nearly as entertaining. So if anybody follow me, if you need a job, let me know. Just kidding. So moving forward, this is more like my style. I like this. It's more digestible, but you learn the same thing, which is so cool, right? So there should be a supplement up here. It shouldn't just be food, but say we're ingesting foods that give us vitamin D. It's going to make its way down to your small intestine. So if you remember from before, the red and yellow guys, these are D2 and D3. So what happens is, believe it or not, this is an enterocyte. This is your small intestine, the wall of it. So each one of these, if you can note, the little circles, those are actually nuclei. That's the nucleus. These are each one cell, which is kind of cool. So bile salts that are given, through the digestion process will form what's called a micelle, which is like just a big circular globule. That helps that get into the enterocyte area here. Did I click it? And once it gets there, it forms a chylomicron. Now, micelle, chylomicron are both just a sphere, but that pops it into lymph. From the lymph, it's finally going to make its way to the blood from a vitamin D binding protein. Okay, so now we went from small intestine, moved into the bloodstream. Liver gets a shot at it because the liver filters the blood. Okay, so again, look, we have a circle. We have it looks like little hair, like almost like a old Bart Simpson, but these are each a cell. Okay. This scattered part is called the endoplasmic reticulum. I call that the liver of the cell. So we're looking at the liver of the cell of the liver. But so all you need to know is a lot of molecular reconstructing happens there. So it comes out, goes here into the endoplasmic reticulum. This is where the first piece happens. We're going to get in the 25th position of vitamin D2 or D3 or the molecular structure. It gets hydroxylated. So that arrow is huge. I'm sorry about that. It gets a big OH on it. So I know it's very small, but it moves back into the bloodstream. And there in the 25th position, there's going to be a new oxygen and hydrogen. That's important because this vitamin needs to be activated. So it eventually lands back in the bloodstream and then heads its way onto the world's largest kidney. So there it is here, moving into the kidney, specifically the proximal tubule. This is what it looks like. This is organic chemistry, so I don't want to go too deep into the weeds. But each one of these corners would represent a carbon, okay, a carbon molecule. And based on how their chemical electromagnetic properties are, they form shapes. So right here is where an oxygen and hydrogen came on. This would be called 25 hydroxy cholecalciferol or 25 hydroxy D. So in the proximal tubule, we're actually going to add and create an active form. So the kidney is what creates the active form of vitamin D, okay, also known as calcitriol. I put an arrow here because what makes it active, so the liver made this OH right here, this OH. Now right here is what the kidney does and creates an OH there. So that those two little guys make the world of difference, okay? Everybody following? Okay, somewhat, good, good. Thank you. So if you really want to have a tongue twister, this would be 125 dihydroxy cholecalciferol. Just call it vitamin D. So now that we're active, I'm taking you to where the next stage is, and this is where I'm going to start, maybe influencing you as to why it's a hormone. Remember, hormones are made in the organism. Remember, this is in your skin. You can activate it. You can ingest it, but you can also activate some in your skin. So we have DNA. That's the gray part here, okay? This little RNA polymerase, it's called, that's an enzyme. It reads the DNA and makes pre-mRNA. So that's like an opposite copy of one strand, okay? That is, it becomes mRNA. Now, people might know mRNA from other times that were recent with vaccines, mRNA vaccines. So that's what that piece would be. That can be a whole nother discussion. That would move down as a ribosome reads it and spits out little amino acids that are clumped together called a polypeptide. That's actually a protein, okay? So DNA being read creates a specific protein. That's how you were created, Where does active vitamin D come in? So calcitriol or active vitamin D would actually go to an area of this polymerase that those sit on DNA in different areas, okay? It'll come down and trigger a response for that certain sequence of the DNA to be read to create a certain protein. So it goes essentially there, okay? And it'll make a certain protein. So it's transported through fluids and stimulates cells into action. So let's go back to vitamin versus hormone. Vitamin cannot be synthesized in the organism. Well, that's a check against that. At all or not in sufficient quantities, and it's required for proper functioning and metabolism in an organism. So a hormone produced in the organism, vitamin D in the skin, stimulates specific cells or tissues into action, goes right down to the DNA to stimulate specific action, right? Regulates physiology and behavior. Definitely a regulatory mechanism. So hopefully you think it's more of a hormone at this point, but we'll keep going to teach you more. So again, you're going to get little references. I'm just referring to, I pulled it out of that reference there. You saw D2 and D3, right? So why do you always see D3? Like we sell basically just D3. I don't think you can even purchase D2 in the store. One of the reasons, I mean, you can just go on the internet and find a plethora. If you want to go to a better source, maybe go to pubmed.gov and look there. But this is a comparison of D2 and D3. This is literally the title of that paper. This was a systematic review and meta-analysis. So remember, meta-analysis looking across a lot of studies, systematic review being structured into what they're looking for. They indicated that D3 is more efficacious at raising serum 25 hydroxy D concentrations. So all that's missing is the activated part of the kidney, okay? So vitamin D3 was better at raising that serum piece right before the kidney activates it. That's what we're looking for. That gives the kidneys control to kind of activate it. I mean, to get active, truly to get active vitamin D, you need healthy kidneys and a liver. If you don't, you have to supplement accordingly, right? Your diet's not going to do it for you because your kidneys might not be converting it as much as you'd like. And so they say, and thus vitamin D3 could potentially become the preferred choice for supplementation. Well, it did, and it makes sense. So I've talked about like a systematic study, meta-analysis, cohorts, case control, random controlled trials. I haven't spoke about that one, but that's the traditional medicine's gold standard. That could be a whole seminar on itself. But studies and case reports are honestly necessary components to healthcare. They build trust. They build validity. We want evidence-based. We want predictable results. You don't get that without having a control and a variable, right? So you can have that on the level of anything you're studying, including supplements. This isn't a plug to orthomolecular, but that's one of the brands we carry. They do some studies similar to that, which I really enjoy because I do like evidence-based because it's more predictable. So when you hear me say these certain studies, if you want to write one down and ask me about what it means, I can tell you. But otherwise, I guess take my word for it that the studies have credibility to them, and you can always refer to them yourselves. But big piece, evidence-based. Little study there. From 2017, so kind of old, I apologize, but benefits of the hormone, got a little arrow. So going back to remember where it landed on the DNA, they found that when it lands on the DNA, there's at least 500 different areas, essentially, of the DNA that it's getting the ribosomes to create the protein from. So that little clump of your DNA would be considered a gene, right? And also further is a phenotype, which is a branch of a gene. But you get at least 500 genes that drive a variety of physical functions. So vitamin D alone, 500 different mechanisms that we know of at least. It's phenomenal. One being cognitive health. The title, the low vitamin D in association with cognitive impairment, dementia. Okay. Several reviews and meta-analysis of cross-sectional studies, case control studies. I mean, this whole thing is just flexing about studies. Flexing meaning showing, validity in studies. Suggested an association between low vitamin D, cognitive impairment, and dementia. Okay, keep that in mind as it clicks over. There we go. So same thing. The 500 genes that popped up again, cognitive health. Same title. Moreover, I had to break this up because it would have been so tiny if I had this on the same one. But it's the same study. They're suggesting that vitamin D levels in specific cognitive domains have suggested a strong association between low vitamin D and a range of executive dysfunction. So the lower your vitamin D, you're going to be more impaired with your processing speed, mental shifting, meaning like moving about, multitasking, driving a car, then your phone rings, that type of thing, and information updating. So taken together, all those studies, this is right from this comprehensive review. This body of evidence suggests that vitamin D may be a new paradigm for therapy in the prevention and treatment of dementia and Alzheimer's disease. They're currently still doing studies about this, right? Yeah, vitamin D is been heavily explored, but it's still kind of the tip of the iceberg as far as how many different things it helps upregulate, downregulate, express. Very interesting. So this is pretty cool. So carcinogenic related mortality, what that means is death from cancer. Another study. So I gave you some cool visuals. Now I'm giving you wordiness. I apologize, but we're getting a little everything on this one. 50 trials, 75,000 participants. Okay, that's a pretty big study. Vitamin D supplementation was not associated with all-cause mortality. What that means is vitamin D was not associated with killing you. Okay, they give the stats to give it credibility. Cardiovascular mortality, so it was not associated with cardiovascular mortality, so it's not going to affect your cardiovascular system in a way to create mortality, death, or non-cancer or non-cardiovascular mortality. Basically, it's saying vitamin D is not shortening your life. They have not found any evidence of it doing that whatsoever. What they did find, which is statistically significant, put a big old arrow there, vitamin D supplementation statistically significantly reduced the risk of cancer death. How amazing is that? I mean, out of 75,000 people, it harmed no one and significantly reduced the risk of cancer death. This is vitamin D. I mean, go vitamin D. This looks kind of funky, but once you put in the picture, boop, there we go. So upregulation of calcium channels is another benefit. I didn't want to see, I went too wordy for a while, and I was like, I need a picture. So now we're going to take a little stroll in the picture. So upregulation of calcium channels. Why would that matter? Upregulation of calcium channel means more calcium in your body. It means calcium gets to where it needs to go, like your bones, your teeth, hardening, right? So here's calcium. This little arrow shows a calcium transporter. This is that, remember that enterocyte cell I showed you where it became a me cell? Vitamin D became a little me cell, right? This is that same place. So vitamin D comes in, and this little hormone goes all the way to DNA and tells DNA to upregulate these calcium transporters. So DNA is pumping out proteins that form transporters, go to the surface, sucks in more calcium. It also tells it to upregulate what's called calbindin. It's a protein that helps pull calcium across the cell, right? What the cool thing is, it's forcing DNA to express proteins to make different pieces, within a cell. So that transports calcium over to the calcium pump. So vitamin D is upregulating calcium transporters, a binding protein to get it into your blood. That's my beautiful blood vessel. So that's the benefits of vitamin D. It's going to upregulate. It's going to help you absorb calcium. And that's physiologically how it's done. One way. Immune system function. So vitamin D receptors are expressed on immune cells. We do know this to be true. VET, antigen-presenting cells, macrophages. Vitamin D can modulate the innate and adaptive immune responses. So an example, gram-negative bacteria. That's one of the, like Pseudomonas, I believe, is gram-negative. So gram-negative, if you get sick with that, it's likely to kill you sooner than a gram-positive. When people go to the hospital, they really got to attack gram-negatives quick because they can overtake a body, cause like sepsis, things like that, quicker than gram-positive. It's because it has like a lipopolysaccharide, it's called LPS. So that's unique to gram-negative. The cool thing about vitamin D helps modulate certain receptors for macrophages that eat LPS. They find it and they kill it. Vitamin D helps upregulate that. So vitamin D has actually been shown to help prevent like severe gram-negative threats, more or less. Just side note. Immune cells and autoimmune diseases are responsive to beneficial effects of vitamin D. So this is found through it helps with inflammation. They've kind of found that, also circling back to innate and adaptive immune responses. There are toll-like receptors that this will kind of modulate to bring down autoimmune dysfunction. So that's another beautiful thing that it does. Prevention of respiratory illness. So this was like a side note, and this is not all inclusive. I mean, there are many other things, like it helps with rickets for children. It helps with diabetes. I mean, I just didn't want to fit this all in there. I mean, you guys, it's phenomenal. Remember, 500 different expressed genes, So in a prospective double-blind placebo study using an objective outcome, this is kind of cool though, if you can follow me with this. In a forward-looking, no patient knew what they were getting, either a placebo or vitamin D, study, using not a qualitative, how do you feel on a scale of 1 to 10? Oh, I feel 7, I feel 6. No, they had quantitative, 2 + 2 = 4, period. Nasal pharyngeal swab culture, so sticking it way up there, and not self-report. So this wasn't the patient even reporting this test. They had to go in, they didn't know what they got, someone else did it for them. And a therapeutic dose of vitamin D showed that vitamin D administration resulted, again, our favorite word, statistically significant, 42%, pretty big, decrease in the incidence of the flu. Putting a big arrow there again. Oh, my arrow moved. Sorry, I made this on Google Docs, made it to PowerPoint. My arrow moved, I apologize. But what I'm trying to prove here is vitamin D in a therapeutic dose resulted in a 42% decrease in the incidence of flu. So flu season, please take your vitamin D. Long story short on that one. Statistically significant. Don't take my word for it. Take their word for it if you want. Osteoporosis prevention. Here's another reference. So I didn't want to use words here, so I'm going to give you a map, a little visual. So what you're seeing on, this is called the y-axis, the vertical one. This is called the x-axis, okay? Femur, neck, BMD. BMD stands for bone mineral density. So if you had, this goes from 0.6 to 0.8 on their scale here, what we're showing. If you had a negative reading, it's most likely osteoporosis, okay? I forget exactly what integer it is for osteoporosis, but they do bone mineral density testing. I know it's hard to see, I apologize, but let's see if the lines match up here. So I'm cutting this in half because on the left side are people that are vitamin D deficient. I guess I underline this too. On the right side are people that are either very low but not technically deficient per our guidelines in America. But you'll note that their bone mineral density for people that were just at 20 nanograms per milliliter, which is the bottom end of being, having efficient vitamin D, they're clearly above people who were vitamin D deficient. So we have a clear representation of how vitamin D prevents osteoporosis with a bone mineral density score. So thought that was proof in the pudding too. Role of vitamin K. K-force. It's right over there. I take that every day, so thought I'd throw that in there. Vitamin D and K are both fat-soluble vitamins, play a central role in calcium metabolism. So I try to give you the points because, in the body, everything's contingent upon everything else. This makes this, makes this, makes this, makes a result. Vitamin K helps through its carboxylation of osteocalcin, it's called. Well, what is that? Well, osteocalcin guides calcium into the bones and prevents its absorption in organs. So if you remember my slide before about calcium upregulation from vitamin D was getting calcium basically in your body, right? Vitamin K, specifically K2, does it more efficiently. We'll take that calcium and put it where it needs to go. Does that make sense? Vitamin D will get it in your body. Vitamin K will make sure it doesn't end up in your cardiovascular system and have plaque buildup. So this is how I wrote it. Vitamin D helps bring calcium in. Vitamin K helps organize it within. Okay, so that's why those two work together very, very well. I know it's kind of a small slide, sorry, or a lot going on, but what are the goal serum levels of vitamin D? This is from the National Institute of Health .gov, the Office of Dietary Supplements, 2022 or 2022. So this is the most recent of what their guidelines are. So under 12, deficiency, okay, 12 to 20, generally considered inadequate for bone and health. Over 20, considered adequate for bone and health in healthy individuals. So that's barring any comorbidities. Over 50 is linked to potential adverse effects, particularly at over 60. So keywords here, linked to potential adverse effects. Now, I'd love to see, because they actually wrote, this is straight from their office, .gov. I didn't get to delve into where they get the linked from, but I don't want to scare you. I had a patient come in. They were at like 170 nanograms per milliliter, and they're just fine. Just fine. So, but I wanted to give you what, the government would state about this. So this might be hard to see. I'll try to explain it to everyone. Vitamin D, toxicity, should I be concerned? This is from this study here. Kind of interesting. So this is the age. So I'm going to take an example. So that what happened in the study is there was manufacturer labeling errors. They had given out vitamin D at like 1,000-fold, what it should have been. And then some of these are iatrogenic, meaning they came from like a hospital-related error or whatever. But the age, for instance, we had between like 40 and 58. Their vitamin D dose was 1.8 million international units every 2 months. 1.8 million, or 970,000 every month. These patients were getting that. Can you imagine? Their vitamin D serum levels between 645 and 1,220. Remember, the government said above 50 is linked to. We have, and obviously we have adverse events here, but 645 to 1220 is phenomenally high. But let's see what their symptoms were. Usually it's a symptom of hypercalcemia because it builds your calcium up. And they're not, they are definitely severe symptoms. They shouldn't be taken lightly, but they're not the end of the world, in my opinion. Fatigue, thirst, polyuria, nausea, vomiting, more thirst, polyuria, muscle aches. So none of that, I mean, that vomiting, of course, sucks. And having to urinate all the time is not the greatest thing in the world. But considering how high their serum was, I mean, that is not too bad. Taking you to another patient, age 75 years old, they were taking 50,000 international units, which we sell once a week. They were taking 50,000 international units a day for a whole year, every single day for a whole year, 75 years old. They were at 243 for a vitamin D serum level. Their symptom, altered mental status. That's it. 50,000 units a day, every day for a year. So what I'm trying to push to you guys is don't be scared of the ranges that were said initially. I think it can be more individual. And some of these benefits that I was relaying to you before from all these studies, you might have to go above 50 nanograms per milliliter to obtain. Okay, so don't be afraid of that. And I'll speak on that a little bit more too. I think I had some arrows in here highlighting stuff. Oh yeah, I was just highlighting that. But 50,000 a day, only altered mental status. You go. Good for you. So how can I test for vitamin D? It's usually a blood spot. So you get like a little lancet. It just kind of pokes your finger. You put it on some paper of some sort, right? And like we offer this here. You can do it at home, and then it has a self-mail-in. You mail it in. You get the results in about 2 to 3 weeks, but you know what your levels are. And you should test every 3 to 6 months when supplementing. So your diet alone, in my opinion, is going to keep you, at least where we live. We don't get enough sun routinely enough unless you're like a snowbird type to activate enough D3. Your diet isn't going to give you enough active vitamin D, so you should supplement. But you definitely want to know where your levels are at to see if you're deficient or not. See if you're on the low end of adequate. And then what are your goals? If your goals are to obtain some of those benefits I was talking about before, preventing flu, working with dementia or Alzheimer's disease, MS, right? All of those different things, you can probably achieve at a little higher level. I will state too, this test we offer for $75, which is worth it if you want to know what you're dealing with. ZRT, the laboratory, they've had 60,000 of these tests done. So they have a lot of data on at least the population that's going to ZRT. Now, that's not going to be a perfect representation of our whole population, right? It's going to be usually people that are already supplementing that want to know their levels, because if you don't care about vitamin D, why would you even care about getting a test? So it's likely people already supplementing. But out of 60,000 tests, they found that 86% of those people, and this is straight from ZRT, 86% of those people, their ranges were from 20 nanograms per milliliter to 80 nanograms per milliliter. That's 30 over on the other side. And they, at least from ZRT, said that no one's reporting to them, at least, any clinical significant side effects. So they actually adjusted what they deem as a guideline. They raised up their level, what they considered adequate. And now that number I don't remember, of course. I remembered all the other stuff, but not that number. But it's higher than what the government was saying at this time. But know your level, guys. So in summary, I mean, hopefully this was helpful. This is my first one, so thank you for being patient with me. According to recent literature, I'm calling you out. You're likely deficient, okay? If you're over the age of 65, 61% of you are deficient. If you're under 65, it was 30-something% of you are deficient, okay? So let's go ahead and know our level. Raising serum levels takes time. Dr. Blum, I believe her name was, she wrote a book about kind of helping your immune system, but more in a natural way instead of using like traditional medicine. Anyway, she's still working with patients. In her book, she had a patient. His level was in the low 20s. I want to say 24. Okay. She found that low to be what her goals were for him. So she had him take 5,000 IUs, international units, a day, every day. And he came back in 6 months and he was in the low 60s. Okay. So it took him at 5,000 IUs a day, every day, an adult man. He went from low 20s to low 60s. All right. So that kind of gives you a general estimate. He had healthy kidneys and liver and kidneys. a general estimate of how long it can take to really move this. And if you're deficient, say you're in like 10 or teens, you're really going to want to start raising that up. And then, of course, you're not going to get that through your food, so supplement accordingly. All right. Let's see what else we got here for you. Just a big thank you. Hopefully that was worthwhile, and I'll answer any questions now. I think this is when the live stream's over, breaking the fourth wall, I think it's called. Or, I forget the name. Yes,
Getting
dear.
back to something you said early on about cholesterol and the composition of vitamin D, does it raise your cholesterol levels?
Good question. No, it's a lot of molecules share certain common pieces.